Welcome to this video. We will look at a ranking and segmentation study of validator behavior. In this video, we will focus on coding in RStudio to get all the outputs there are in this study. Let's get started. First, let's use tidyverse package to load the data. So first, we'll need to put in the tidyverse library. We can load our data. Let's call that valid_raw. Validator data.csv. And we can use sample and function to look at a few random rows. So if I put 5, you get 5 random rows. And also make sure that it's in the right working directory where your file is. And let's see if this code will run. Great. So we have this data set here. So we can click, actually if you want, we can click on valid raw to look at the whole data set. So we need to clean the data a little bit. For instance, current balance and effective balance. We need to parse the number so that it's numeric. For proposed, we need to split up these and parse the number. Eligibility epoch, activation epoch, exit epoch, and withdrawal epoch. We will also need to convert it into numeric. And we have this genesis here. We will just make that 0. So let's get started on that. And yeah, and the first column is just index, so we don't need it. So let's get rid of that too. So we have valid raw. At first we can select -x1. That will just remove that column. And we need to mutate post column first into ASCII before we can separate it. But for that, we will need the string I library. So trans general propose Latin ASCII. So now that it's in a good format, we can separate it into 3 separate columns. We have assign, executed, skipped, using the separator space, and we want to merge it into the data set. And then we can parse all of these. We can parse the data. So we have a few of them that we want to parse. We have the 3 new columns: executed, skip, and then we also have the current balance and effective balance column. So what do we want to do? We want to parse number. And then we need to convert those 4 other columns into numeric. So first one, eligibility epoch. So if it's Genesis, you want to make it 0. So we can do if else eligibility epoch. If it's equals to Genesis, we want it to be 0, or otherwise it's just itself. Alright, so this whole thing here, we want to make it numeric. So as dot numeric of the whole thing. So we need to repeat the same thing for the other 3 columns. So I'm going to copy it 3 times. And then we want the activation epoch. We want the exit epoch and the with epoch. And then let's run. The code. Okay, it looks great. It looks great. Let's save it as valid dataset. Great. We relooked at the data. So we can use the scheme.r library here to just look at some statistics. Scheme valid. So it's a nice command that produces a simple summary table. Right? We have the number of rows, number of columns. We have 1 character columns. We have 1 logical columns, and we have 10 numeric columns. And also we have the mean, standard deviation, and all that here. Right? So that's great. And next we can look at activation. So activation, let's find out how many validators are activated over time. So we can sort the data by using the arrange function. Then we can group by activation epoch. Then we can count it using summarize. Let's give it a name. Let's call that num activated. Now we can take a look at the first few rows. Okay, so it looks like this. So we can actually draw a scatter plot very easily, right? But to make it a little bit nicer, we can ignore this activation epoch at 0. So let's do that. So we have the num activated, and to remove that we need to use filter. So activation epoch, that is only the greater than 0, so it doesn't include 0. And then we can use the ggplot. Activation epoch, y is the count. And then we can do jump point because we want scatter plot. Let us see how it looks. Not bad, right? We can of course add the title, and we can change the X, Y axis labels, and also we can add more ticks to the X and Y axis. So let's do that. Okay. So to add ticks, we can use scale, Y, continuous, breaks, right? We can use the scales package. We have the pre-breaks. Let's use n equals to 10. We can do the exact same thing for the x-axis. And to add title, we use labs. So title, we can say activated validators over time. We can call the x-axis activation epoch. I can call the y-axis number of activated validators. Now it looks pretty nice. So you can see most of the epoch, there are 4 new activated validators. So we can also look at the time series on the total number of validators. So to do that, we're going to first create a new column that cumulatively add the counts. So we can do mutate, cum count. There's a nice function called cum-sum, cumulative sum of the count, and we can just plot it, right? So we can plot it. So x equals to activation epoch again, y is equal to the cum count, and we want a time series, so we can use the geom line. And similarly, we can use the same codes to have more takes, and also the title, the x-axis, the y-axis, and so on. So the y now is the cumulative number of activated validators. So let's see. I should use plus here. So perfect. So you can see here and here we have some anomalies, and it suggests that there was some fault in the network's activation functionality. So next we have the exit column. So we can calculate the amount of time it takes a validator to exit. So we can create time to exit variable using the formula here. Each epoch is 6.4 minutes, so we multiply by 6.4 and divide by 60 to make it into an hour. So we can look at the distribution of this, and to do that, we can just do mutate to create a new variable, time to exit. We have the 6.4 divided by 60 times exit epoch minus activation epoch. Then we can use ggplot again to do distribution. We can do a histogram, which is just geom histogram, like that. Let's see how it looks. It looks good. Again, we can maybe add more ticks to the X and Y axis. We can add some colors and boundary to clearly see the cuts. So let's do that. We can do fill for the color of the bars. I'm using type of red and orange color here. Then for the boundary of the bars, use color. Using gray. And then we can do a similar thing with the scale. We just copy it from above. And then we can add a title. Distribution of time to exit for validators. You can also change the X to time to exit, and it's in hours. Let's see how it looks. It looks great. It looks great. So here we can also look at the table to see exactly how many validators exited, as well as other summary. Okay. So let's see how we can do that. So we have the valid data set as before. Let's just copy here. So we have the valid data set that we created, that we can get the time exit using this formula. Then we can filter out the null values. So let's filter out the null values. So is NA will give us all the null values. The exclamation will give us the non-null values. So let's call that exit time. So now we can look at the summary, and we can use the scheme function again. So we can do scheme exit time. I'm only interested in time to exit, so we can just do that. So we have on average is 363 hours, which is around 15.1 days. Okay. And the fastest exit time is less than 1 hour, which is 0.96 here. Right. Great. Now it's your turn. We can look at these trends over time with a time series plot and a cumulative count graph that tracks the number of validators exiting throughout the epochs. So you will try to get the data, which is counting the exit epoch and obtaining the cumulative sum, and then display through random rows. And second, you get the summary of the count. Third, you plot a time series of the count and color the line blue. And fourth, plot a time series of the cumulative sum. So you can pause here, you can try it yourself, and when you're ready, just click unpause. So first, to get the count, we will do something similar that we did before. Right, first we have to group by the exit epoch. But notice that here there are a lot of null values, so again we need to get rid of those null values just like before. And then we can just use summarize. And then we can create another column that will give us the cumulative count. We can call this exits, and we want to view 3 random rows, so we have sample and exits, comma 3. Okay, hopefully you got that. And to get the summary of the count, we can again use the scheme package. So we can do that. Okay, great. And third, to draw that, we can simply just use ggplot. We have x equals to y, exit epoch, and y equals to the count. And then we want it to be a line. We want the color to be blue. Right? Looks something like that. Of course, you can add the title. You can make the more takes on the x and y axis if you like. And lastly, we want a cumulative time series, so we can do the same thing with ggplot, but now we use the cumulative count. So the data set, we have ggplot x equals to the exit epoch, and y is equals to the cumulative count. We want the geom line. Right, that's basically it. Right, like that. And again, you can make the x and y takes. Again, you can add a title. Right, you can change the x and y label and all that. But I'll leave that up to you. Let's continue. So next, we can look at the block proposal process. So we have the assign, executed, and skip column. Well, we will look at distribution of all of these. Right? Of course, one way to do it, we can just do each one. Right? For instance, right, we can just do valid dataset, and then we just group by assign, and then we just do ggplot like that. Oh, sorry. Plus, we can do geom bar, and we can give it a title like that. But we can do that very easily, and we're going to repeat it for executed and skip. But let's do it another way. Okay, let's just draw 3 of them together using some nice function. We have the facet wrap function. So let's do that together here. So we have the dataset valid, and we will focus on these 3 columns. So I'm gonna select this column, and then we are going to collapse it using gather. And then we're going to group by variable and value. And we're going to plot each one of these. We're going to color each one by its variable using the fill parameter. And then we're going to do a jump bar. And then we're going to use a facet wrap on the variable. And we're going to facet wrap it in 3 rows. So as you can see, it looks like that. Here we can also add a title like before. With distribution of assign, executed, and skip blocks. And also, this legend here is really unnecessary because we already have the title here. So we can also get rid of that by using theme legend position equals to off. Looks great. We observe that each validator status is distributed exponentially. The average validator has been assigned to 6 slots, has successfully proposed 4 blocks, and has meets 2 slot assignments. Right. A quick exercise for you. How would you get the average mention in one shot? Let's take a few minutes. Right. Pause the video and come back when you're ready. So one way to do it is this. So we can do very similar thing that we did just now, where we're going to select the assign, executed, and skip. We're going to again collapse it using gather. And we're going to group by the variable. And then we're going to summarize. And we want the mean of the value. So hopefully you got that. It's your turn again. By treating the executions and assignment skips as proportions, we can visualize the distributions of both execution success and skip slots as rates. To do so, we define each variable by taking the number of executed or skip blocks and dividing them by the total number of assigned blocks. Your job is to create 2 histogram plots that show the distribution of execution rate and skip rate. Give clear titles and different colors for these two plots. Again, pause the video and come back when you are ready. So let's look at the first plot. We have the data set. We first, of course, need to create a new variable, execution rate, which is just executed divided by a sign. And then we can just use ggplot to plot it. Rate, and we have to use histogram, give it a color. You can use red, you can use whatever color you like, and give it a nice title. We can do distribution of execution rate for validators. So let's see how that looks. Looks pretty good. We can do a little bit more. We can fix the Y, how Y labels looks, and the X label as well. Okay, for instance, we can do this. We can change the Y label using scales package again. So we can do the labels scales, comma, use the comma function, and then we can do the breaks as the same as before, scale pretty breaks n equals to 10, for instance. Then we can make the x-axis as percentage. We can do labels is equals to function dot scales percent dot, we can do accuracy equals to 1. And then we can do similarly breaks as same as before. Let's see how that looks. Looks pretty good now, right? It has the commas on the y-axis, and we have percentage now on the x-axis. So we can do a very similar thing for the second problem. As you can see, we can just simply change execution rate to skip rate, and everything else basically stay the same. So I'll let you finish that yourself, and we will look at slashing. So what is slashing? It's an act of punishing validators for a violation. So we will investigate the number of slash validators over exit epoch. Let's do that. We have the data set. First, we need to fill out the slash validators. Right. The indicator is true. We can group by the exit epoch. Like that. And then we can summarize the count like before, and then we can also do the cumulative count again like before. Then we can just use ggplot to plot it. count. Want a time series, we can do jump line. We can make the X and Y axis nice, just like before. We can add a nice title as well. Like number of slash validator over time. We can have exit epoch on the x-axis. We have the cumulative number of slash validators as well. So that will give us a nice time series. Pretty good. So you can see that between 2000 and 4000 we had a high jump on number of slash validators. Since 4000 the growth has been much slower. Next, it is our goal at this junction to develop a categorization method that can codify patterns in validator behavior, characterize it, and discern the difference between constructive and destructive network actions. To do so, we will employ a weighted linear rank scoring algorithm. As input, we will use current balance, number of successful executions, the active status of the validator, how long the node has been active, the number of skips assignments, and an indicator for whether the node has been slashed. And we have most of these ready in the dataset, and it's easy to get the others. In particular, two of the variables, the number of skip slots and whether the validator has been slashed, indicates negative behavior, so we will need to put a negative weighting on those. So here's what we need to do. First, we create a variable active that indicates the active status. We will replace the null value of the exit epoch with 15,579. And then we're going to create the active time, which is the same formula as before. And then we have the execution and then putting the negative weightings. Let's get to the coding. So we have the data set. First, we need the variable active, which is just whether the exit epoch is null value. And then next we have to modify exit epoch using if else, depending on whether it's null. If it is null, we will replace it by 15,579. Otherwise, we will keep it the same. Then we can calculate the active time just like before. 6.4 divided by 60 times exit epoch minus activation epoch. Then just create a new column called execution, which is basically executed, and make slash opposite or negative. In this case, it's a binary indicator, so we use the exclamation mark. And finally, we make the skip slot negative. And finally, we will select the public key, the index, and the 6 variable that we have discussed: current balance, executions, skip, slash, active, and active time. We will save this into valid underscore stats. Now that we have the variables that we need, we can try to implement the algorithm. So we have the 6 variables. We will get the order ranks and multiply by its respective weights, and we add them up together to create a score. Let's see how we can code it and get the score and the ranks. So we have the data sets. First, we will need the rank of each of these variables. We have the current balance, execution, skip, slashed, active time. We're gonna have rank, and here we will divide active time by 4 so that we have less weight on active time. Then we use gather again to collapse the data. With the rank, then we can group by the public key, and we will just summarize by adding up the ranks. And we will mute, and then we will compute, create a variable rank by ranking the score, and at the end we can arrange the rank. And let's save that as valid ranks. Great. Okay. So now we have the score and the rank. We'll put them back into the valid stats data frame. So we will use left joint, and also we will revert the slash and skip back into the original value. This can be done very quickly here. We have the valid stats. We need to left join the valid ranks, and we have to mutate the slash back to its original form, and the skips back to its original form as well. Then again we can arrange it with the ranks. Let's save it called valid all. I'm missing a percentage sign. Great. So we can look at the rate of change of score by simply plotting it. So we have the valid all. We can first arrange the score and create a new variable called index, which is just the row number. And then we can use ggplot to plot it. We have the score. Then we can do a jump point. I very quickly see how it looks. It looks like this. Okay. So we can use a color scheme here to make it looks like that. Here we can add some colors to it. Right, depending on the scores that you get, we can add some colors to this plot by using color equal to score, and using the scale color gradient n, where we can use two colors here. And again we can make the scales a little bit better. We can have the scale continuous. We can have the labels be scales, comma, and the breaks is scale pretty breaks, n equals to 10. For the y continuous, we can do the same exact thing actually, so let me just copy and paste. And we can add a nice title, sorted validator scores. Let's see. Right, so we can see that we have a pretty nice graph here. Let's plot the distribution of the score. So we have the data set, ggplot, x equals to the score. We can use histogram. And we can do the same scale that we did before, and we can add a nice title. Okay, so let's see how this one looks. So it looks pretty good. As with many unsupervised tasks, the transition from scores to segmentation is often tricky. There's no well-established subject matter context for selection of cutoffs, nor one agreed upon cluster validation method in the literature to appeal to. With some intuition and mathematical hand-waving, we settle on the selection of 7 score tiers to differentiate network behavior. As follows, we have rank 1 to 2,489 as tier 1, and so on. So let's just copy this code here. We're basically just using if-else statement to create a new variable called tier. So let's go back to our RStudio, okay, and run that code. So now we have the tiers as well. Great. Now it's your turn to recreate the sorted validator scores shown below. The color will show different tiers. Pause the video and try it yourself and come back when you're ready. So this plot is very similar to the plot that we had before. So let's just modify this code to get what we want. So first we're going to use the valid tiers dataset, and then we need to color it by tier, and we want to have 7 colors because we have 7 tiers. And to get the right color like the picture, we have to do REV to reverse the color, and that is it. Let's see if we get the right plot. Perfect. Okay, great. Let's now try to create this plot together. For this, we will need to use geom rectangle, and for the colors to fill in everything nicely, we'll have to create this data frame for that. This is basically just adding a column and 2 rows so that the color will reach out to infinities and negative infinities. So we'll just copy this code here and go to RStudio, and you will see how it looks like. So you can see we have one column that is shifted down, and then we add an infinity here, and in the last row we added a negative infinity for the lower score. Okay. So now let's try to get the plot that we want. It's very similar to the plot before, so we can copy that code and then modify it as we go. So we have valid tiers, then we have arrange, we have mutate, these are all the same, and we don't need the color equals tier anymore. We need the geom point, and we need to add the geom rect as mentioned. We're going to use the data that we created, which is valid summary. We need to have the inherit.aes to be false because we're using 2 different data sets. And now we have to look at the xmin, xmax, and so on. This is negative infinity. Y xmax is equals to infinity. Y min is equals to the score, and Y max is equals to the high score. And also we need to have the color. In this case, we're going to use the factor of tier so that it becomes discrete value. And finally, we need to have the alpha equals to 0.2 to make it a little bit opaque. Okay, and we need to change this into scale fill manual, filling tiers, and the values is the same color, the reverse rainbow color 7. And we can modify the title a little bit. We can add a subtitle and say that is with tier cutoff illustrated. So let's see how that looks. Perfect. Right, so we now have this very beautiful graph. Okay. So we can do a very similar thing to our histogram before, where we can create this partition color for the histogram. So let's see how we can do that. So we had the histogram from before, but we can just do it right now. So valid tiers ggplot, we have the score, and now we need to fill it with different colors of the tier. And we need to have the geom histogram, and we can just add a boundary color, say gray 60. And then similarly we can make the x-axis a little bit prettier by using scales comma, and we can add breaks if you want as well. Right, scales pretty breaks and equals to 10, for instance. We will also use the scale fill manual like before. Right, the tier and the values is the ref rainbow 7. And let's give it a nice title: distribution of validator performance scores stacked by tier. Let's see how that looks. It looks awesome, doesn't it? And we can also use faster wrap on this, right? So we can simply add a faster wrap command so that it looks like this. So we can separate it by the tiers. Okay. To categorize the behaviors of the tiers, we can look at the mean of the 6 variables that we use in our scoring system. So let's create a table that will let us look at the mean. So we have the valid tiers. We can group by tiers first of all. We are also interested in how many validators are in each tier, so we're going to add a count column, and we can summarize that. We have the We want to find the mean of the count. We want to find the mean of the active time, current balance, executions, skips, slash, active, and score. And what do we want to do? We want to do the mean of that. And we can also multiply the slash by 100 to make it into a percentage, similar with the active as well. I just make it a percentage. And now finally, let's rename all these names to just for better visualization. We have the count, we have the time active, we have the current balance, we have the successful blocks, we have the skip blocks, and proportion slash, and finally proportion active. Let's give it a name. Let's call that the summary table. And let's see how that table looks. So we have the tier, the count, the time active, and all that. So these are the mean of each of the tiers. So we can actually have like a heat map on it by using format table. So let's load the library format table, and then we just do format table of that summary table and see how that looks. So it looks a little bit nicer than what we had before. And now let's see if we can try to make it a little bit colorful. So we can do it like this. With, again, format table. We want the summary table. And we have the list of things that we need to do. Well, first we have the time active. We will just use color tile for each of these columns. It goes from red to light green, for instance. So we need to do the same for the other columns as well. To save time, I've already copied it here, so you can see it here. They are basically just the column names and then the color tile. Here for the skip blocks and proportion slash, we flip the color because these two have negative effect. So let's see how that looks. Looks good. Looks good. So that's how we can format our table with heat map. Now, There's some characteristic behavior of each tier that we concluded. You can take a look at that. Now finally, we can look at a principal component analysis that we had. So to do that, we simply just use the prcomp function to do the principal component analysis. So we have prcomp valid all dataset. We will select the 6 variables that we use for our scoring, or we can deselect the other columns that we don't want, which is score, rank, public key, and the index. And let's save that as PCA, and we can look at the structure of the PCA with str. So it looks like that. With the principal components, we can now use these components to draw a contour map and color it by tiers. And let's see how we can do that. We can do valid tiers. We just get the tier information and then combine it with the principal component. And let's make it a nice data frame. And we can just use ggplot. And here we will do the third component and the first component. And then we color it by tier. And for the contour, we use the geom density 2D. And again, we need the scale color manual to be tier, and we use the same color, the reverse, rainbow 7. Let's see how that looks. Looks like that. And that's how we can draw a contour map. And that concludes our video for this case study. I hope you enjoyed it. I'll see you next time.